Welcome to Vidhai. Everything is possible. So once again, hi all. In this video, we'll be discussing the continuation path from magnetic field. So guys, now we are entering into a new subtopic. It is magnetic field. It is defined as the space around a magnet in which its magnetic effect or influence is observed. So what does it mean? It means the space around the magnet till which the magnetic force can be felt or experienced is known as magnetic field. It is measured by the units Tesla or Gauss. Now look at the direction of the arrows. They represent the force acting. You can see the direction of arrows is from North Pole to South Pole. So this whole direction tracings is known as magnetic field. So this is called as magnetic field. So as magnetic field is an important topic, let me give you a few more examples so that you can understand it in better way. Look at this air cooler and light. So first, air cooler. If you turn on this air cooler, you can experience cool breeze from it. So till where in your house you can experience the cool breeze from the air cooler, you can say that area as the field of the air cooler. Actually, you can't say in this way, but I'm telling you so that you can understand it. So the cool breeze is termed as the force and the air cooler is termed as the magnet in the actual magnetic field topic. Okay, so till where you can experience the force from the magnet is called as magnetic field. Similarly, you can relate this example with light. Now to know more briefly about this topic, let us follow the following activity. So the activity is you need to take iron fillings and place them on a piece of paper. I need to place it on a table. So what you need to do is you need to gently remember the word gently. You gently tap the table. You gently just push the table. So what happens is you would see the following pattern on the piece of paper. You would see the magnet attracts the iron fillings in this way. There will be a different strange pattern. You'll be having few questions. Why only this pattern? Okay, think about it. Don't worry, I explain you. It is because of the direction of the magnetic force in that field. Let us learn more about this with some small activity. First, you need to take a bar magnet and keep it on a piece of paper. Then you need to take a pen and a compass. So what you need to do is you need to place the compass near the North Pole. Now you need to see the reading, the needle. You need to see the needle and the you need to label a point where the needle shows the North Pole. So you need to point that point with the help of a pen. Now what you need to do is you need to remove this compass and place it on the point which you labeled just before. I need to continue this. So what you will observe is you will observe this pattern. So when you join the points, you'll be observing this pattern. So this is the result. So this is you can say that this is the direction of the magnetic force in this magnetic field. And the another property is magnetic character of these substances is not affected by the external temperature. So these are the properties of diamagnetic materials. Now we'll go with the second materials, paramagnetic materials. So we will learn their properties first. As we learn first, when we place them in a uniform magnetic field, what happens? If you place these paramagnetic materials in a uniform magnetic field, what they do is they place themselves in such a way that they are parallel to the direction of the magnetic field there. And if you place them in a non-uniform magnetic field, they will act in opposite way from that of diamagnetic materials. They move from weaker part to the stronger part of the field there. Now they get magnetized in the direction of the field. It is also quite opposite from that of diamagnetic materials. And now we will be discussing few paramagnetic examples: aluminium, platinum, chromium, oxygen, manganese, and solutions of salts of nickel and iron. And another property is The magnetic character of these substances is affected by the external temperature. Means if you give a temperature, if you heat these paramagnetic materials, they lose their paramagnetic nature. Now the third type of materials are ferromagnetic materials. So first, as usual, we'll be learning how they behave if they are placed in external magnetic field, which is uniform. So when they are placed in external uniform magnetic field, what they do is they try to place themselves in such a way that they are parallel to the direction of the magnetic field present there, which is similar to paramagnetic materials only. Now, if you place them in non-uniform magnetic field, what they do is, like paramagnetic materials, they try to move from weaker part to the stronger part, but that too very quickly. So this is the difference. These move quickly from the weaker part to the stronger part, and they get strongly magnetized in the direction of the field. Like paramagnetic, they also get magnetized in the direction of the field, but here they get strongly magnetized. And examples of these ferromagnetic substances are iron, cobalt, nickel, steel, and their alloys. So generally we call these are magnetic materials we see in our daily life. And the magnetic character of these substances is affected by the external temperature. Means when you heat these ferromagnetic materials, they change to paramagnetic. Now there's a chart here which compares dia, para, and ferro. You can pause the video and you can learn more from this chart. Now we entered another interesting subtopic, that is Earth's magnetism. So in the directive property, we learned that when you suspend a magnet, it places itself in such a way that it points towards north-south direction of the Earth. And did you ever wonder why this happens? Why only this north-south direction? So all this you'll be learning in this Earth's magnetism. So this shows that Earth behaves like a huge magnet. So it means if you take this magnetic north pole and magnetic south pole, when suspended, are aligned in such a way that the north pole of the magnet points towards the geographical north direction and the south pole points towards the geographical south direction, because scientists believe that Earth acts like a huge imaginary magnet where its north pole is present near the geographical south and its south pole is present near the geographical north direction of the Earth. And this is why the, the magnet that we are suspending is attracted by the north-south poles of the Earth. So, thus it's appropriate to say the magnetic north pole of the needle is attracted by the south pole of the Earth, which is located at the geographical north, and vice versa. Now, what is the value of the magnetic field strength of the Earth? It is 25 to 65 microtesla. So remember this magnitude, 25 to 65 microtesla. So that's all about this. Earth's magnet is 20 times more powerful than fridge magnet. The strip of the back of the credit card that you use is magnetic strip, often called as mag strip. The mag strip is made up of iron-based magnetic particles in a thin plastic film. Each particle is really a very tiny bar magnet about 20 millionth of an inch long. So this is the image. This black area is called as magnetic strip. It's made of tiny iron-based magnetic particles. So that's all about this. Let's sum up the topic. Magnets are classified into two types, natural magnets and artificial magnets. Magnets attracts things made up of magnetic substances such as iron. The force of attraction of magnet is maximum at the poles. A freely suspended magnet always comes to rest along the geographical north-south direction. Like poles of magnets repel while unlike poles attract one another. Materials which are attracted by the magnets are called as magnetic materials, and those which won't attract are called as non-magnetic materials. Based on the behavior of magnetic field, magnets can be classified as diamagnetics, paramagnetics, and ferromagnetic materials. depending on their ability to retain their magnetic property. Artificial magnets are called as permanent and temporary magnets. The south pole of the imaginary magnet inside the Earth is located near the geographical North Pole, and the North Pole is located near the geographic South Pole. In ancient times, the magnet, in the form of direction stone, helped seamen to find the directions during a voyage. Magnets, especially electromagnets, are used in day-to-day life. Nowadays, magnets are used to generate electricity in dynamos. Magnets are used in computers and storing devices such as hard disks. They are used in debit and credit cards also. Just before you have seen that magnetic strip, mag strip. That's the example, the end. Thank you for attending. Please check the description below the extra questions and lectures for each chapter. Exams Vidhai. Everything is possible.